Okay. Could you give a recap of the Transcendence rocket mission?
Yeah, so basically we have our rocket here on the test stand, or launch stand, and then it's going to launch. It's going to have about a 15-second burn duration, and the thrust that it's going to have on takeoff is going to be about 24 kilonewtons. We wanted to keep that duration as short and as possible because we need to get really fast off of the tower so that we're not affected by the wind so much. You'll also notice that the rocket is spinning, and the reason for that is because we want to have spin stabilization, and this will damp out a lot of the perturbations that happen during the flight from things like off-center thrust and wind and other types of perturbations. Once we reach the Karman line, we're going to separate the vehicle. So the booster half will go away, the nose cone will be on its own. The reason for that is that we have a really small parachute to save on mass, so we don't want to have to take the extra mass and systems we would need to recover the entire body. The body's really heavy, so it's nearly 100 kilograms, so that would be like a really big parachute we need to bring all that back. And then the nose cone will basically fall all on its own, back down to Earth. It goes really fast when it does this. It comes up almost to Mach 3 as it's descending. So this is why we need to first open a drogue parachute to kind of slow it down to a speed in which we're able to open up the main parachute. The drogue parachute will deploy roughly at about 5 to 10 kilometers. We're not really certain on the exact altitude yet. And then when we've slowed down the payload to a reasonable velocity and we've come down a bit more, we open up the main parachute. And we just want to reduce the amount of drift that the payload will experience. So we try to open that main parachute as low as possible. And then, yeah, we'll land either in the middle of the woods somewhere in Sweden or somewhere in the ocean if we have an ocean launch site. So it could be a wet recovery.
Yeah, and of course we want to check the apogee, and once we recover, there's going to be a beacon on it to ensure that we can find it, and we want to check what altitude we went to and how the sensors functioned when we get the black box back. Yeah.
How close are you to reach space from 1 to 100?
Oh man, maybe like 13. I don't know. We haven't really built anything yet, so you have to keep that in mind. A lot could change. We could think we're at like 50 when we're actually at 10. So yeah, it's hard for me to say exactly where we are. If we had once we start testing in a couple of months, we'll know more where we are. Because if things are working and as we expect, then we'll actually be quite far down the path. If something is very vastly different from what we expect, then we could be coming back to the design a bit more.
Instead of an absolute answer, I think at this point it's going to be the rate at which we can kind of increase on that scale. It's going to be pretty high with reviews, pretty much higher with the testing. So I think the growth rate is going to be faster because we have an ambitious goal in the end. And yeah, it's not about where we are right now, but I think where we will be in a little bit of time. Yeah.
Yeah. So in the scale you have here, you're saying 1 is a water rocket and 100 is a Karman line. I would say we're probably going to be somewhere near a 10 to 15 in a couple months, because that's when we're going to have our small scale rocket demonstrated. Yeah, orbit is definitely 10,000. Yeah, that's about right on that scale. In terms of the propulsion that we chose hybrid, which is maybe a curious choice. In terms of like how hard it is to build and stuff. Obviously, it's really whatever propulsion system you choose, it's always going to be difficult. I think the more conventional route is to go with solids, because you can actually build a smaller vehicle with a solid design, because you only need to think about one tube, put the solid propellant into it, and then that's basically your rocket, and you can send that up. So in terms of like design complication, it's much simpler to think about and a lot simpler to design, because all of the variables inside of that are known. Like you can a lot of times the propellant grain is like the regression rates are all known. Like you can read about them and you can kind of just implement the same type of strategy. So you can kind of start at a design phase and end up at a solution, I think, quicker because of the experience that's there. With hybrid, it's a bit more difficult because you have a fluid that you're dealing with, and the behavior of that as it flows into the combustion chamber can be quite complicated. So there's a lot more testing I think that you have to do in order to make sure that it's performing the way you expect it to. Yeah, there's that, and I think that complication is probably similar to a liquid fuel rocket. Liquid fuel tends to be a bit more complicated though, because now you have two fluids that are flowing. But I don't know, depending on who you talk to, sometimes hybrids and liquids, some people would say, no, don't even do hybrid, it's not even worth it, just make a liquid one. In terms of multi-stage rockets, I think that's something you need to be a little bit more experienced with before you start playing around with, because lighting a rocket is actually more complicated than it seems, and lighting it while it's flying is vastly more complicated. Yeah, that's like, imagine trying to ignite a lighter while traveling on the highway at 100 kilometers an hour. Like it's a bit difficult.
Where do you want to test your rockets, and where do you plan to launch them?
Of course, this is subject to change and subject to availability with respect to time slots. As you can imagine, when we're going to a commercial agency or an entity, we kind of don't get as much priority as previously booked slots for testing. So essentially, we hope to test with the German Aerospace Center sites in Traun or in Lampothausen. Of course, this is not set in stone. Nobody's promised us anything. This is just the desire that we have, that we want to test with them. Regarding launch, we're looking at a few launch sites. One is the S-Range launch site, of course, from Sweden. We also have Spaceport 1 and Shetland Islands. Maybe Jesaiah can talk a bit more about them geographically. So these are just with respect to propulsion and launch. However, there's a bunch of other tests that we have to do along the way. We have to make sure the avionics works really well, and that we definitely have some kind of estimation with the altitude and the functioning of the sensors. And for this, I think we can perform a lot of tests in the hack space, which I mentioned previously. Recovery plans to also look for permission for flying the aircraft somewhere at different altitudes of up to 2,000 to 3,000 meters to test the drogue and the main chute. We want to do the pressure test, of course, which again, hopefully is supported by the German Aerospace Center. And there's also a couple of test sites that we're looking for vibration tests. One is in ETS, European Test Services in Netherlands, and the other one is also DLR in Bremen. So yeah, we have a few options and a few possibilities, let's say, and a lot of interest to test them. And in the end, we're going to have to see which dates work out with which facility.
Yeah. It can be a little bit challenging to find a good place in Europe, just because it's kind of similar to what I said before about it being so populated. If you want to do anything propulsion related, one thing you always have to think about is noise. The neighbors don't like it when you light a rocket in their backyard. Rockets usually have about 140 to 160 decibels of noise, so you can hear them from quite a ways away. Yeah. In other places, maybe you can sometimes get away with this because it's remote, so you can do it somewhere where no one is, and then it's not such a big deal. But for the geography of our launch sites, if you want to launch a rocket to go to 100 kilometers, you're really restricted to where you can do this. The downrange distance that the rocket will travel is nominally about 50 kilometers, and it could be as much as 100 kilometers. So you need to have a launch site that has like that much area where there is no people. So you can't really do this anywhere in mainland Europe. There is the only launch sites that we're really aware of at this time that are really able to host this type of stuff are all in Scandinavia or in northern United Kingdom, or in southern Spain. Anywhere where they're kind of like where they're going over water or over a really remote area. For smaller launches, you can find some places that are potentially suitable. So in Germany, usually you can get stuff. You can launch something that maybe goes less than 5 kilometers. I know that High End launched one of their small scale demonstrators at a military range in Germany, and that went to about 3 kilometers. But you need to be connected with the military to get something like that happening, and we're working on that right now. So if the Bundeswehr is listening, please let us launch our rocket at your sites.
Yeah, we're just students wanting to do research, so essentially it would be great to have that. For example, for the place we're in, there are a couple of airfields that allow up to 1 kilometer and 1.8 kilometers maximum if you go 40 kilometers from here. They're all airfields for model rockets or any experiments, but as you can imagine, this is not as useful for us to launch to 1 kilometer. So we do need to get to a place, we do need to get clearance for a higher altitude. I think the major problem is, just like Jesaiah said, quite some population across a really small area. And Germany is pretty restricted with respect to dropping stuff from the air, with respect to launching both. So in order to keep in the boundaries of the regulation and still meet our goals, it is quite a bit of a trade-off.